Okay, on this page, we're actually going to apply the Pythagorean theorem a little bit. We're going to find the area of each shaded region. And in this diagram, you have a big triangle, but this is the part that's being shaded. But one thing they didn't tell you is that this one over here is also 29 inches. Now, I'm looking just for the shaded part. Do we have any suggestions on how to find the area of the shaded part? Okay, good. We're going to use the area of a triangle. I totally agree with you. So I'm going to go area equals base times height over 2. The rules for this have stayed the same, okay? I have to have my formula written first, okay? However, I need to find the base, because this triangle right here, what's really cool about it is that it's a right triangle. And I can use just that triangle to help me out. But in order to do that, I need to know the base and the height. Well, there's a few things you should already know. If this one's 29 inches and this one's 29 inches, that's an isosceles triangle. And if this is a perpendicular, it comes from the vertex angle, what does it do to this side? It bisects it. So that means this side is 20. And I'd let that be my base. Now, the problem is, I don't know the height. Is there any way that I can, calculate the height? I hope you'd say, oh, it's a right triangle. We're just learning Pythagorean theorem, so probably the Pythagorean theorem. So to solve for height, I'm going to use the Pythagorean theorem. So I go over here, a squared plus b squared equals c squared. I'm going to plug it in. I get 20 squared plus height squared equals 29 squared. I get 400 plus the height squared equals, and then 29 squared. And by the way, remember that's your hypotenuse, that's why we're putting it in. H means height, not hypotenuse in this case. 29 squared is 841. Subtract the 400. So height squared equals 441. Now here's my hint, friends. Go ahead and see if you can take the square root of it on your calculator. What do you get? A nice number. It's 21. So the square root of 441 is 21. Now I know the height. I know the base of this one, so that's cool. I can plug it in. Area equals our base, well that's 20, times our height, which is 21, all over 2. So that should equal, if you're simplifying it out, should be 210, in this case labeled square inches. So that's A. Now, you should hopefully be able to get that. Now, I'm looking at the same type of scenario for B, okay? I'm looking for it. I want to find the area of this triangle, the whole thing shaded. I'm going to turn this for just a second. Is that still an isosceles triangle? Okay. So if that's still an isosceles triangle, would this perpendicular segment right here, and I'm going to draw it in a little bit darker, would that bisect this base? So that make that 6. Now, notice I said bisects that base. If I was solving for the area of this triangle, this whole side would be my base. And then if I go to my highest point and go straight down, that's going to be my height. But again, what's missing? I'm missing the height. So can I use a right triangle to help me solve for the height? Yeah, I'm going to use the Pythagorean theorem again. So I go over here and I go Pythagorean theorem, a squared plus b squared equals c squared. So if I'm using this right triangle, this would still be my hypotenuse, plugging it in. So I will go, and then this would be my side, not 12, it'd have to be 6. So I go 6 squared plus the height squared, and I'm going to change that so it's this direction so we see it, equals 14 squared. So that's 36 squared plus the height squared equals 196. I go ahead and square it. I subtract 36 from both sides. That's going to be 160. When I take the square root of that, that ends up being the square root of 16 times the square root of 10. What does that give us? 4 root 10. So my height is 4 root 10. Notice I didn't give you permission to change it to a decimal, so you have to stay that way. So leave it as 4 root 10. But now that's my height. Here's my height. Here's the big base of the triangle. So area still equals base times height over 2. The base, the whole thing is 12. The height, we calculated that. That's 4 root 10 all over 2. So 12 divided by 2 is going to be 6 times 4 root 10. That's going to be 24 root 10 square centimeters. All right, so notice when we solve for area now, most of the time you're going to have to calculate something using the Pythagorean Theorem or another right triangle. I say most of the time, I'd probably say 75% of the time. You're going to have to use right triangles to your advantage. Now, notice the next one. I changed the directions for you. It says find the length of the hypotenuse, use your calculator, and round your answer to the nearest whole number. This time, I want you to use your calculator. But the process in showing the work, you still have to do the same thing. So you ask yourself, can I use the Pythagorean Theorem first? Yes, that's a right triangle. I'm looking for C, so I'm just going to even call it C, the hypotenuse this time. So my Pythagorean Theorem is leg squared plus leg squared equals hypotenuse squared. I plug them in, 24 squared plus 39 squared equals my hypotenuse squared. And if you plug this all in, I do know those two add up to 2,097. I'm sure you're so excited. This is where our calculators come in handy. But I still have to take the square root of it. So when we do that, I get it to be approximately something like 45.79, something else keeps going there, okay? So if I'm going to go to the nearest whole number, I look one spot past it. It's 5 or larger, so I round up. So that's going to be 46 inches. Now, if they say you can use a decimal, go ahead, but notice I still had to do all the work before I got there. You don't really want to use your calculator to the very end. Okay, now we still haven't used our theorems on the second page. How to classify. If you do it this way, you'll get it right. If you don't do it this way, you're not going to get it right. So make sure you work with these. So I'm going to use the fact that I have inequalities or equations to help me out. Make sure they're always lined up smallest to largest. So that way you can always assume this is A, B, and C. A, B, and C. A, B, and C. So that way I always know the longest ones because they have to go in order. So the first thing I want you to do is just go A squared plus B squared, C squared, leave a gap. I'm going to let that be done at the very end. So I just start putting my numbers in. 6 squared plus 9 squared. And then I have C squared, which is 10 squared. So 6 squared is 36. 9 squared, 81. 10 squared, 100. So 36 plus 81 is 117. So 117 is greater than 100. So I move that to the top. And I get A squared plus B squared is greater than C squared. So when is A squared plus B squared is greater than C squared? When I have an acute triangle. So what type of a triangle do I have? Acute. Pretty easy. So that's how I'm going to work with it. Now I'm going to use the exact same process on the next two using what I know. So here I go A squared plus B squared, leave a space, C squared. So when I have that, it's 18 squared plus 24 squared, be 30 squared. So 324 plus 576, because I go ahead and square them. 30 squared is 900. That's an easy one. So then I let my math happen here. 324 plus 576 is 900. Oh, look. 900 equals 900. When I have A squared plus B squared equals C squared, what type of triangle does it have to be? Right triangle. I bet you guys can guess what the last answer is. Yeah, I'm going to give an example of each one. But using the same process with this, it will be very helpful. So with this one, I have A squared. I'm going to have B squared. Here's our C squared on there. We'll see if it works. So we're going to go 20 squared plus 100 squared. And then I got my 110 squared. So 20 squared is 400. 100 squared is 10,000. And 110 squared is 12,100. So it's 10,400 is less than 12,100, right? So I put my less than symbol here. And then I would flip back. A squared plus B squared less than C squared is an obtuse triangle. So I know that it's obtuse. And you will have to do that on some of these, and they'll just say, how do you classify them? And that's how the process you do, exactly like this. This is in homework and your future tests, so make sure you know how to do any of this problems here. Any of these are fair game for the test coming up in about 2 weeks, a little less than 2 weeks. All right, next question. Is this diagram true or false? Basically, I said there's a right angle there, but is that really true? Well, how do I do it? I'm going to set it up just like what we did before. If that's my longest side, I'm going to see if these can work. So I'm going to go 50 squared plus 60 squared, 71 squared. So that's 2,500 plus 3,600. 71 is 5,041. So I get 6,100 and then 5,041. That's greater than. Are they equal? No, they're not equal. It's greater than. So it is a what type of triangle? Acute triangle, not right. An acute triangle, not a right triangle. Because, I'm going to say it like this, A squared plus B squared equals C squared. Didn't work. All right, so that gives you the why a little bit behind what we did. Oops, let me move that up there for you. So a lot of what we've been doing builds off of what you did last year. I'm going to tell you the harder parts for you. It will be the very first example on this page, and it's going to be just making sure you follow the rules. I would have my homework very close to me, the notes. You might have to use right triangles for Pythagorean parallelograms, but make sure you have those. These give you a lot of different examples, but they should help you do a great job. All right, guys, call me if you have questions. You know my home number. You can get a hold of me then.